Okay, section 7.2, part 2. So what do we do with that? Well, let's say that I give you an equation or a problem that says, I want the inverse sine value of 1. In other words, I'm looking for the angle that would have a sine value of 1. When I look for the angle that has a sine value of 1, in other words, where is sine of theta equal to 1? Now, we've done that problem before. We've done this over and over. Where is the sine of theta equal to 1? Well, we look on the unit circle, and 1 occurs when the angle is pi over 2 or 90 degrees, your choice. But we have to ask ourselves something a little more now. Is pi over 2 in the range? Is that an output that we're allowed to get? And yes, it is. We can go from negative pi over 2 to pi over 2. So that answer is the answer we're looking for. But let's look at one where we have some other questions. Like, where is the sine of theta equal to negative 1/2? Well, we've had that question before, but the sine of theta is equal to negative 1/2 in 2 places, in quadrant 3 and in quadrant 4. So that happens at 7 pi over 6 and 11 pi over 6. Okay, that's fine, except we know that it can only use the one from quadrants 1 and 4, so I'm going to put down 11 pi over 6. And now I need you to ask yourself, is that in the range? Is 11 pi over 6 in between negative pi over 2 and pi over 2? And it's not. And since it's not, I need a coterminal angle. This is not the answer to the problem. But instead, I'm going to need a coterminal angle that is in that range. I'm in the right quadrant, I'm just in the wrong range. So let's take a look at 11 pi over 6. What is a coterminal to that? We can either add 2 pi, which would just make it bigger, or we could subtract 2 pi, making it smaller. Now, 11 pi over 6 is greater than pi over 2. Pi over 2 would be 3 pi over 6. So this is obviously bigger than 1/2 pi. So I'm going to subtract 2 pi, find myself a common denominator, and that's going to give me 11 minus 12. Oh, 11 minus 12 is negative pi over 6. Now, is negative pi over 6 in the correct range? Yes, it is. Then we know we have the right answer. Well, let's take a look at this problem. It says inverse sine of 1/3. That means where is the sine of theta equal to 1/3? Now, we know that's going to be in quadrant 1. It's positive. Sine is positive in quadrant 1, negative in quadrant 4. So we know we're looking for an answer in quadrant 1. We're looking for an answer that is in between 0 and 90 degrees, or in between negative pi over 2 and positive pi over 2. So let's take our calculator and do inverse sine of 1/3. Make sure that you are in radians, or if you're in degrees, you know you're in degrees, and it doesn't matter to me whichever one you're trying to do. But if you're in radians, you should get 0.34 radians. Well, 0.34 radians, I don't know if that answer is in the range or not, because I don't know how to compare pi over 2 to 0.34. So take your calculator and divide pi over 2, and you're going to find that that's approximately 1.57. And this is negative 1.57. Is this in between negative 1.57 radians and positive 1.57 radians? And it is. Now, if you are in degrees, then your answer will be 19.5 degrees. That is another acceptable answer. Just make sure that you label your answer with whichever one it is, so you and I both know what we're looking at. Same thing for inverse sine of negative 1/4. If we are working at inverse sine of negative 1/4, negative 1/4 would be in quadrant 4. So I'm looking for an answer that's going to be in quadrant 4. And so when I take this, I say, where is sine of theta equal to negative 1/4? I put that into the calculator, inverse sine of negative 1/4. And in radians, I'm going to get negative 0.25 radians. Negative 0.25 radians. And if I'm in degrees, I'm going to get negative 14.5 degrees. And both answers are acceptable answers. So what if I have a problem that's a little more complex? What if I'm looking at a problem that says the inverse sine of the sine of pi over 4? This is a composite function. This is a composite function. I have the inverse function with the composite function of itself of some value. Remember back when we had the inverse function of the function and we knew we had found they were really inverses when it got us back to x? Well, that only is true if x is in the domain. Well, let's look at this problem. Whose domain am I going to be checking? Am I going to be checking sine domain or inverse sine domain? Remember, the innermost function, the one that we are plugging in, is the most restrictive domain. So I have to look at the sine function we're going to look at. Let's go back up here to this table. And my sine function has a domain of negative pi over 2 to pi over 2. Is pi over 4 in that domain? Well, it certainly is. So since it's in the domain, the functions undo each other, and the answer is just pi over 4. Well, let's look at this next problem. The next problem says inverse sine of 3 pi over 4. Well, I'm looking at the sine function, so I'm going to the sine function, I'm looking at its domain, negative pi over 2 to pi over 2. Is 3 pi over 4 in that domain? It is not. So you have to think to yourself, where is 3 pi over 4? 3 pi over 4 is over here in quadrant 2. That is not a quadrant I can use. But remember on the unit circle, there's another angle over here that has the same reference angle. Where is that? That is at pi over 4. So I can rewrite this problem as the inverse sine of the sine of pi over 4, and pi over 4 is in the domain. I am allowed to use that, so the answer is simply pi over 4. Okay, let's take a look at this next problem. We've got the sine of the inverse sine of 0.5. Well, that's the inverse sine is the innermost, so we're going to look at this domain, negative 1 to 1. Is 0.5 in the domain from negative 1 to 1? It is, so the answer is just 0.5. Inverse sine of 1.8, we're going to look here, negative 1 to 1. Is that in between negative 1 to 1? It is not. And unfortunately, this is not an angle. This does not have a reference angle or anything else. This is a number because I'm just trying to find the inverse sine. I'm looking for the angle when I'm given the sine ratio, and that can't be changed. That means that this answer does not exist. Since this is outside of the domain negative 1 to 1, which is just a set of numbers, it's not angles, there are no reference angles, there's no coterminal angles we can look for, that answer does not exist.